All right, today we're going to take a look at arithmetic sequences. We've talked about recognizing patterns, and we even talked about whether it was an adding pattern or a multiplying, dividing type pattern. And we identified that the arithmetic patterns were the patterns of addition and subtraction. So we're going to kind of take it to a next level today. We're first going to start off by identifying some definitions. Some we talked about in our last lesson, kind of like the definition of a sequence here. Sequence is an ordered list of items. We see that in our math terms right there. Here's a consideration we're talking about. That's just a list of ordered numbers. And then the next definition, where we're going to get into today, sequences like the one above are called arithmetic sequences. And the reason why they're called an arithmetic sequence is the sequence in which the difference is consecutive of the consecutive terms is constant. This difference is called a common difference. So what we're looking for is a common difference between each of our terms in the sequence. And then the other thing I want you to note, as this is the notation for a common difference. It's the italicized lowercase d. So we've got a couple of examples from the Springboard book. We're not going to go to those. I've made copies for you, and you can just watch as we do these. And what we're asked to do is determine if the sequence is arithmetic. If so, state the common difference that we see. So we'll do that now. We see to go from the first term of the sequence, from 3 to 8, is an addition of 5, and from 8 to 13 is also an addition of 5, plus 5, plus 5. So what we do have here is an arithmetic sequence. Yes, it is. Yes, it is arithmetic. And the common difference is equal to positive 5. And notice I said positive 5 because the common difference can also go down. All right, let's take a look at the next, number 2 here. We go from 1 to 2. Well, if that was a difference, that would be an addition of 1. And from 2 to 4 is an addition of 2. So we don't even really need to check to see if this is an arithmetic sequence, because once it fails that, it is no longer arithmetic. We can kind of look ahead a little bit and see, okay, if it's not addition, then might it be multiplication and be a common ratio, which it is. And then number 8, what we're going to do is just continue a pattern. So the pattern we see, if we find the missing terms in the arithmetic sequence, to go from 19 to 28 is an addition of 9. So we would add 9 to get to our next term, which would be 37. We would add 9 to get to our next term, which is 46. And then we see that our pattern did work out, because plus 9 would get us to 55. And then the last thing we would have is 9 plus 55, which is 64. So the pattern that we're looking at is a arithmetic sequence, and it has a common difference of 9. All right, go ahead and start writing this formula down as I read our definitions as we go through this. This is the most important formula that we'll see today. This is called our explicit formula. The terms in an arithmetic sequence can also be written as the sum of the first term and a multiple of the common difference. And this formula is, like I said, called the explicit formula. We can use this to pick those terms. Now, we won't always have the luxury of just being able to move 1, 2, 3, 4 steps down the line. If I'm asked to find the 176th term in a sequence, I'm not going to want to count over. I could, but I'm not going to want to count over 176 common differences to get to that. So this is our formula. This is what's going to get us there. All right. Just so we know, we need to identify what these terms are. We've already identified what the D stands for, which is the common difference. That's the common difference. That's the change that we see happening between each of the terms. The n value will be the number in the sequence we're looking for. And then the A, it's called A sub 1. I'm saying A sub 1. A sub 1 is the first term in the sequence. And these letters are also going to work when we start talking about series as well. So we get this formula down here, and we'll be ready to use it. So here's an example that I was talking about. Finding the 40th term in a sequence that starts at 6 and has a common difference of 3. So essentially what this is saying is 6 moving up to 9, moving up to 12, moving up to 15. I could obviously do this 40 times and figure out where we are headed. All right. So instead, what we're going to do is use the formula that we just saw on the last screen, which is the first term in the sequence, A sub 1. And then we are going to add it to the number in the sequence that we're looking for. In this case, that would be 40 times the common difference. Now, what this formula essentially does is we subtract 1 because the common difference is going to happen if we're on the 40th term. We're going to have experienced that common difference 39 times. So the minus 1, what that essentially does is it regulates that for us because that's how many common differences we are going to see. So in this case, we know that our common, the number in our sequence that we're looking for is the 40th term. And we're given the common difference. So we'll write our common difference here on the outside. Whoops, common difference of 3. This can be put into our formula. This could be solved by hand, whichever method you want to do. But I'm going to take an extra step that you don't need to. But again, we have 6 plus every time we move, we're going to go up 3, and we're going to go up 3 39 times. So that's where we get to where we're going. So when we put this in our calculator here, we should get 123. And we're going to go one step further. And we're going to note this the right way. A sub 40, that is the 40th term in the sequence, is 123. All right, now we'll take a look at the next one. The next one, it doesn't give us the information quite as easily, so we're going to have to do a little bit of work, but it's not a lot. The first part is not very difficult. The A sub 1 is the first term in the sequence, so our A sub 1 in this case is clearly 37. And then what we're going to look for next is our common difference. Remember, all we've got to do is subtract the first term minus the second term, and we'll see that we've actually gone down 4. We've gone down 4 to the next, and we've gone down 4 to the final term. So we do have a common difference, and that common difference is -4. So what we'll do is we'll take this to our formula, which is the first term plus the term we're interested in. In this case, we're interested in the 30th term, n minus 1, times the common difference, which is -4. Notice the parentheses. If you don't put that in parentheses, you're going to have issues because it would end up looking like subtraction. Another method you may want to do on this is put it in front of your parentheses. Then you don't have that issue. This would also work. So we'll take that to our calculator, see what it thinks about it, And again, what this has done for us, it has allowed us not have to take all those steps to get to our term. And this number ends up being negative 79. And we would call this a sub 30. So here we're going to get into some actual word problems. I mentioned this yesterday or in our last lesson that these have a lot of applications. Algebra 2, we don't run into a whole lot of applications, but this is one section that we actually do. But it says Hope is sending invitations for a party. The cost of the invitations is $5, and the postage for each is 45 cents. Write an expression for the cost of mailing the invitations in terms of the number of invitations mailed. Then calculate the cost for 16 invitations. Now, I feel very confident that most of you are going to be able to find the cost for 16 invitations. But don't be afraid of this explicit formula. It's actually really easy if you just remember, hey, there's only 3 parts. The 3 parts being a sub 1, the first term in the sequence, the common difference, and then the number we're looking for. Well, the first term in this sequence clearly is going to be $5. Hope is going to spend $5 regardless of what we have. That would be our first term in the sequence. The common difference, the change that we see is what the common difference is. Well, the change that we see is going to be the 45 cents for each stamp. And then lastly, we're looking for the number in the sequence. In this case, that would be the 16th invitation. Now, we do run into one thing on this that we need to think through. Our explicit formula, you'll remember, is a sub 1 plus n minus 1 times the common difference. And if you recall, I told you that we did the n minus 1 because the first term in the sequence doesn't experience that common difference. It doesn't experience that change. But in our application here, we do run into it mattering. Because think about this. If we were talking about the first term in the sequence, if we're talking about sending one invitation, the invitation cost is going to clearly be $5. And that first invitation is going to need the 45 cents. So in this case, our formula, if we use our explicit formula, it's actually going to come out wrong. We will not need to minus 1 on this one because the first stamp is actually going to have to be paid. The postage is going to have to be paid. So in this case, we're looking for a sub 1 plus the number times the common difference. All right, so let's work this one through. We know that our starting value is $5. We know that the number we're looking for is 16 invitations. And we know on those 16 invitations, we're going to pay 45 cents per invitation. So what we end up with is $5 plus those 16 invitations, which cost 45 cents a piece. So our sequence, a sub 16, would equal $12.20. A lot of times in these patterns, when you miss something, kind of use your common sense if you run into that situation. But a lot of times you're only one number off from the pattern. So most of the time you either have to subtract 1 from the number you had or add 1 to the number you had. Here's another example. Again, I applaud your problem solving skills, but your formula is going to be faster on this one. For some of you, actually, it may not be, but solve the problem. So here's what we have. We have going from 15 to 18 to 21 to 24. What we see is we have a common difference of +3 each of these steps. So we have a common difference of 3. And we clearly know that the first term in the sequence, a sub 1, is equal to 15. What we don't know in this one is what number in the sequence we have. So we'll call that one x. And we actually know the outcome on this one, which is a little different. So here's what we actually do. The formula we would have is 15 plus the common difference. I'm going to put it in front this time. X, because remember I told you I would call n x minus 1. Well, what we have is the outcome of 72. So we're going to set this equal to 72. All right, and then we will solve from there. Now, you could distribute the 3 into that term, but let me encourage you, watch this and see what happens. I want to encourage you to hold off on doing that. First of all, before we do that anyway, we have to isolate these values. So this would be 57 equal to 3 times x minus 1. So if you think about it, if I distribute the 3, I'm going to have 3x, and then I'm going to end up dividing by 3x. So let's save ourselves a step. And instead of distributing a 3, let's divide a 3 from both sides. When I do that, I get 19 equals x minus 1. I would add 1 to both sides. 19 plus 1, of course, is 20. So if I go back and answer the question that was asked, it says which term in the arithmetic sequence is equal to 72? The term in the arithmetic sequence would be the 20th term. Would that have been terrible to count +3, +3, +3? No, but you run into some issues of miscounting, forgetting what number you're on, and this is just an alternative way, but solve the problem. You know, I always emphasize that. Solve the problem. Use your problem-solving skills. Develop your problem-solving skills. And we save the best one for last here. What we're looking at is the 4th term in a sequence and the 12th term in the sequence. Again, problem-solving skills come into a huge difference here. What we need, again, are all of those things. We need the a sub 1, which of course they're looking for. We need the common difference. And we actually don't need the n value on this one. So the big question is, how are we going to find the common difference? We are the 4th term in the sequence. So we have 1, 2, 3 blanks, and then we finally have a number. And then we go from 4 all the way to 12. So it'd be 5, 6, 7, 8, 9, 10, 11. And then we finally have the number 68. So how are we going to do this? Well, what we need to think about is how much change have we seen, and in how many steps did we take to create this change? So let's talk about the steps we've taken. To go from the 4th term in the sequence to the 12th term in the sequence is 8 steps. We've taken 1, 2, 3, 4, 5, 6, 7, 8 steps. And in those 8 steps, we've gone from 20 to 68, so we've increased by 48. So think about how this works. If we've increased by 48 and we've done it in 8 steps, what would each step be? And each step, by the way, is our common difference. So if we divide our 48 by our 8 steps, we're going to get 6 as a common difference. So we have a common difference of 6. It's not the question that we were asked, but it's the first step in getting there. Now, I do not want to go to a formula and create this. However, I could. I could go back to that explicit formula and put this thing together, but I do not want to do that. Let's keep things simple. If we know we have a common difference of 6, every time we move to the right, our number increases by 6. Well, what would happen if we went to the left? Hopefully you're thinking and saying we are going to decrease by 6. So the first step, which would take us to a sub 3, would be 14. The second step, also minus 6, that's why it's called a common difference, would take us to 8. So a sub 2 would be 8. And then lastly, backing up 6, a sub 1 would be 2. All right, involves a good bit of problem solving skills on these things. Reason your way through it. You might surprise yourself.